Continuing from Friday. Today's the 26th. We are almost done with January, y'all. Holy wow. Well, it's just Christmas. We were just out for the holidays. Here we go. Negative 1.5 plus 4. Negative 1.5 minus 1. Negative 1.5 minus 5. What is 4 minus 1.5? 2.5? 2534, yeah. Negative 2.5, negative 6.5. Y'all don't let me make a mistake. Is it looking right? Is it right? I think it is. Where? No. I think of it in money. But I had $4 and I have to pay $1.50. How much money are you gonna get back? $2.50. Okay. Interim reports, like straight up report cards from last. Did we already do that? For this 6 weeks. Interim reports go out Thursday. Y'all probably give them out Friday. Which won't have your test on there, which is kind of crappy. So that will be a 3-week progress, and then 3 weeks beyond. Okay. What is 2.5 times 2.5 is 6 points. Somebody get your calculator out for me quickly. I don't want to do this in my head. I don't want to do them quicker either. 2.5 times 2.5 times 6.5. No, 6.5 times something. It's 6.25 or 62.5. Because that's 25 times 25. With decimals. 25 times 25 is 625, right? Okay, just moving the decimals around. It was going to be some variation of those 3 numbers. 2.5, 2.5, 6, 40.625. 40.625. And we got a negative times a negative, which is a what? And a positive times a negative is a negative. Oh, I have a calculator, don't I? Why am I always forgetting about this? Because I don't use it, that's why. Was it 6.5? No, 2.5. 2.5 times 2.5 is 625. See? 6.5 times 6.5. 40.625 with the negative sign symbol. Okay? So we were right, negative 40.625. Now, what do we have to do with this? What did we just determine? We found the corresponding y values. The corresponding y values for negative 5, which is way up here, is negative 5, positive 60. And then way down here is negative 1.5, negative 40.625. You guys agree with that? Pardon? But I use the slope formula. Why, what would make you think I would need to do that? Because what is a rate of change, y'all? Rate of change is slope. Rate of change is slope. But now, Heather, what am I going to use? My 2 ordered pairs that I just determined. Okay? What, just for kicks and giggles, what's the formula for slope? There we go. y2 minus y1 over x2 minus x1, right? You remember that? You better remember that. Then what are my y values? 60 and negative 40.625. And if I start with 60, then I have to start with what? Negative 5 minus negative 1.5. Now again, just FYI, I am not going to give you something that has a decimal in it. Why? Because you can't, I'm not going to let you use calculators, so that would just be evil. I'm not that evil. I can be evil, but I'm not that evil. Okay? But you know as well as I do that minus a negative is plus a positive, right? And the same thing down here. Minus negative 1.5 is actually plus 1.5. 60.40.625. What is that?
100.6.
Attaboy. 100.625, right? Over, what's it going to be, y'all? What's negative 5? Think in terms of money. How much? 3. Negative 3.5. If you can ever change it into money, you need to. Think about it in terms of money. It's easy to calculate. Here. Now, I'm not calculating that. Let's see what it is. Do you guys agree? You see where I'm getting these calculations from? Everybody cool? Yeah? So 100.625 divided by, what was it? Negative 3.5. You get negative 28.75? Negative 28.75. Negative 28.75. That's the slope of that line. Does that make sense? Here's when we look at it and we go, okay, I crunched the numbers. Does it make sense though? Does the negative sign look right? Is it supposed to be a negative slope? How come? Because if you look at it, the point on the left is up high, the point on the right is down low. If I connect those dots, the line's got to have what kind of slope? Negative. Hey, just for kicks, and let me show you where this is headed for calculus. If I were to ask you about the function f of x, the curve, is it increasing, decreasing, constant from negative 5 to negative 1.5? What would you tell me? It's decreasing. And the slope of the line that connects those 2 points is what? Shut your mouth. It has negative slope, doesn't it? If I ask you about the curve from negative 1.5 to 2.5, is it increasing, decreasing, constant? The slope of the line that will connect those 2 points better be what? It better be positive, right? And then what about from 2.5 to 5? That function is increasing, decreasing, constant, decreasing, and the slope of the line that could connect those 2 points better be negative. Do you see how you can go back and kind of double check? And again, if I give you one of these, it's not going to be with the decimal. Promise, I'm not going to do that to you. Wouldn't do that. Now, I might give you something like this to add up in your head. You better get negative 1.5 minus 1, correct? If you don't, I might have to accidentally bump into you with my elbow. You better not get that wrong, okay? Let's look at this. All right, so if I wanted you to find the average rate of change of this function, negative 2x squared plus 4x plus 6, first of all, what kind of function is that? It's a quadratic function. What's the picture going to look like? It's going to look like what? A parabola. Is it going to be a smile or a frown? Why? Because it's a negative leading coefficient, woman. It is going to look like that, isn't it? And we have to study the interval from negative 1 to from negative 3 to negative 1, correct? So let's talk about the process. How are you going to attack this problem, Tyler? You help. Plug what in? So I'm going to have to evaluate f of negative 3. Just help get me started. Okay, evaluate that. Just do that one and stop, and then I'm going to turn you loose because I don't want you to make a careless mistake right here. I just want to make sure we all together here on this. Who's got it? Where do I start? Go ahead.
I was going to tell you the answer.
Well, I don't know what the answer is until I look it out.
I did negative 3 squared.
Which is? Alright, so then we work backwards like that? Okay. Keep going.
Then on negative 2 times now negative 18.
Okay.
And that minus 12.
Because 4 times negative 3 is negative 12, plus 6. So then we got 10, 20, 30.
36.
You said negative 30? Why is it negative 30? Because it's negative 18 minus 12. So
Thought 2 negatives make it positive.
if it's like this, if they are back like 5 minus negative 1, that's positive. Okay? What's negative 30 plus 6? Negative 24. So now we've got negative 3. What's that ordered pair? Negative 24, right? So we have, does that make sense? Is that going to be a piece on the graph that's down low in the third quadrant? That makes sense. Here's, why did I make you wait on me? Why did I make you do that part? Did anybody put negative 9? Okay, that's good if you didn't. Usually people mess up on their signs and they'll put negative 9. And that's when I want to elbow drop you. Okay? Find f of negative 1, find the corresponding order pair, and then find the average rate of change. Just like we did in the last example. Go, you got 3 minutes. Are we cool with that? So here we go. Let's find the slope. The average rate of change, 0 minus negative 24. Do I have to go in this order? No, but if I do, and you went in the order of negative 24 minus 0 over negative 3 minus negative 1, we should still end up with the same answer in the end, correct? So let's see what happens. I got minus a negative, which is plus a positive. Minus a negative, plus a positive. 24 over 2, which is, how many of you got 12? Hands up. All right, now let's think about this. What am I thinking about? I'm thinking about my parabola. That looks something like this, right? My first point was negative 3, negative 24. There it is. Clearly, that is the point, negative 3, negative 24, right? It looks like it to me. Then there's negative 1, 0. Totally looks like that point. If I connect those two dots, should I have a positive slope? Isn't that kind of nifty? I think that's kind of cool. I think it's kind of cool how it all fits together. Okay? Now, here's what you're going to do. Do you have any questions? Average rate of change really is just going back to slope, isn't it? Okay? So, moral of the story. When a function is decreasing the secant line, which is the line that's connecting the maximum value to the minimum value. The secant slope, the average rate of change, will be, if it's decreasing, the slope will be what? Negative. When a function is increasing, the secant line slope is positive. So average rate of change, whenever you see that right there, average rate of change, it has something to do with slope, which we have been studying since Algebra 1, and when you first found the slope of a line, right? And this is what, when we get to calculus, we talk about the slope, holy moly, a lot, a whole bunch, okay? All right, so here's what I want you to do. This is kind of a change of pace for us because we're kind of in between. So what you're going to do is you're going to do about 5 or 6 problems for me together. I don't care if you work together, that's fine with me. Let me give you a certain amount of time. You got to get these problems finished. If you look at page 40, it's kind of like having classwork in class. So I guess it would be called classwork, wouldn't it? Okay. I want you to do page 40. I want you to do 8 through 10. Folks, this is just describing the intervals as increasing, decreasing, and constant. And of course, share books, okay? Take a picture and put it out there for folks. 8 through 10. I want you then to work on 20 and 21. 20 and 21, that's talking about your mins and maxes, relative and absolute. Just talking about the hills and the valleys. And then 34 and 35, what do you think that's going to be? It's going to be your average rate of change. Okay? 1, 2, 3, 4, 5, 6, 7. That's 7 problems, 14 minutes. You got it on that salmon colored sheet of paper. Okay? Here's what I want you to write down. Okay, we are going over section 1.5, which is parent functions. If I were to throw, if we were to have flashcards, and I throw a picture up there, you need to be able to tell me parabola, absolute value, cubic. You've got to be able to tell me that quickly, okay? Because it's just identification. You may not want to write any of this down, okay? But I at least would write down constant, and I would draw what it looks like. Definitely, I would draw what it looks like, okay? Just for kicks and giggles, and I'm going to fly through this, so you mark your notes 17 minutes, because I'm going to fly and I'm not going to wait on you. What would the domain and range of my constant function be? What would the domain be? Anybody? All reals. What would the range be? Y equals 3. That is going to be the Y value every point on my graph, isn't it? Yes. Okay. The identity function. Why do they call it identity function?
X equals Y.
X equals Y. What do we interchange with f of x all the time? Y. What's the slope of that line?
1.
1. So folks, x equals y, that means that point is 1, 1, 2, 2, 3, 3, and it even goes back to the negative side as well. 0, 0, negative 1, negative 1, negative 2, negative 2, so on and so forth. Right? What is the domain of the identity function? Anybody? All reals. What's the range? All reals. Every single time, okay? Every time. Minute 18, 17, if you want to reference that. Quadratic function. What's a quadratic function look like? It looks like a parabola. This one in particular, is it going to be an upward or a downward turn? Upward. It's going to look like a smile. Here's the easiest way to graph this. A parabola, the parent graph of a parabola, is symmetric about which axis? If it were symmetric about the x, then it would look like this. Is that right? No. So it's not symmetric about the x-axis, it's symmetric about the y-axis. 0, 0, because 0 squared is 0. What is 1 squared? What is 2 squared? All right, so look what I'm doing. I'm plotting the points. 0, 0, 1, 1, 2, what? 1, 2, 3, 4. What's it going to be on the other side? It's going to be the same height. It's going to be the same thing because a parabola is symmetric about the y-axis. And I have little skinny intervals, so it makes it look funky, okay? But if it's a positive leading coefficient, it's turned up. If it's a negative leading coefficient, it's turned down, right? Okay? Cubic functions. What do I call this one? John Travolta. Because where is it going to start? Positive leading coefficient. So it's going to have what kind of a trend? A positive or a negative trend? So if it has a positive trend, which quadrant will it start? It'll start in the third. Now, folks, this one's kind of crazy. Does it pass through the origin? 0, 0, right? 0 raised to the third power is 0. What's 1 raised to the third power? 1. What's 2 raised to the third power?
8.
8. It's 8. Okay? It's going to be way up here. Now we could do the same thing for the negative values. You are going to have to graph at least 3 points on your test, which is going to be on Thursday. I do not want a sketch. I want kind of an accurate sketch, okay? So if I plug in -1, it's going to be -1, -1, because -1 cubed is -1. What is -2 cubed? -8. 1, 2, 3, 4, 5, 6, 7, all the way down here. Boom. Do I have enough points so that I can connect the John Travolta? Okay. So if it had a negative leading coefficient, where would it start? It would start over here, wouldn't it? If it had a negative, if it was y equals -x cubed, wouldn't it look like that? Why? Look at this trend. Do you see how it's a negative line? Do you see how this has a positive trend to it? Yeah? If that will help you. I know I'm going fast, but reference 2145 on your notes and you go back and watch this, okay? Square root function. You will have to plot this point. You'll have to plot points and then connect the dots. Yes, you will. I don't care. 0, 0. Can I take the square root of 0? Can I? I can take the square root of 0. There are things I can't take the square root of. What are they? So, the domain for the square root function is going to be what? All positive reals. All positive x's, right? What about 1? If I plug 1 in, what's the square root of 1? 1. What's the next x value that I want to plug into that function that would be easy for me to calculate and graph?
4.
Is it 2 or 4? Why do you say 2? Just, it's a natural progression, right? I would try that one too. Why'd you say 4? What? It's the next perfect square, isn't it? Okay. 1, 2, 3, 4. If I plug 4 in for x, what's the square root of 4, y'all? 2. What would be the next one I would plug in? Come on, everybody. Which one? 9. Because when I plug in 1, 2, 3, 4, 5, 6, 7, 8, 9. When I plug in 9, my y value is going to be what? 3. Do you see that? And now look at the trend of this function. You're going to have to plot points for that. And they're going to have to be accurate. Okay? Just for kicks and giggles, what's the domain for that? How would we write it? 0 to positive infinity. Included or not? Yes, 0 is included. What would the range be? Be the same thing. Just for kicks and giggles. The more we look at this domain and range, do you think it will eventually sink in? It will eventually sink in, I promise. Okay? How about the reciprocal function? What does this one look like? Now I'm going to just tell you, I don't like the way that one's written. But if I'm typing it, I have to type it sideways. I would prefer to see this written this way. The reciprocal function, which is also what kind of a function? It's also a rational function. But this is one of those special ones. Why do you think it's called the reciprocal? What is the reciprocal? Well, what's the reciprocal of 2? No. Negative 2 is the opposite of 2. It's what? How'd you get that? Because you just flip it over, don't you? You switch the numerator and the denominator. Now, where are the pieces of this function going to be? Say that again. Around the zero, symmetrical to the origin, yes and yes. But where are the pieces going to be? Which quadrants will they lie?
In the first and the third.
First and third, why? They will never touch the, well, that's, I can't say they will never. If it's translated, they will be. But the parent function for the reciprocal, 1 over x, the function, the curve itself will never touch the x or the y axis. Never. Okay? The pieces are in the first and the third quadrants. Now, you have to know that. You have to. What would be the domain and range of this? So if it's, okay, let me back up. I didn't mean to interrupt you. If it's never going to cross the x or the y axes, then this function must have 2 somethings. 2 asymptotes. What kind? This one has a vertical and a horizontal asymptote, which happens to be each of the 2 axes, right? The x-axis and the y-axis. What's the domain? Who's got this? It is. So is it all reals except? Except 0. Except 0. All reals except 0. X equals 0. What about the range?
Same except for y equals 0.
That's exactly right. All reals except y equals 0. I hope you already know this, or I hope you're going to go back and you're going to rewatch this, because I promise this is on your test on Thursday. Promise. And if you get it wrong and you didn't write it down, I hope I don't ever look in your notebook. Okay? Because that's going to make me angry. Just interval notation. Would it be negative infinity to 0, parentheses, union, parentheses, 0 to infinity?
Can we write it either way?
You may. Which do you prefer? Yeah. Yeah, I want you to be able to write it both. But recognize it either way. Okay? And be able to write it either way. Questions at all? No? Absolute value. What's this one look like? This one is the B. Okay? 0, 0, 1, 1, 2, 2. And then negative 1, positive 1. It's also symmetrical about what? The y-axis. This one, domain. What's the domain? You guys agree? What's the range? 0. Is it going to be a parentheses or a bracket? Bracket 0. To positive infinity. Right on? Make sure that your brackets look like brackets and your parentheses look like parentheses. I'm not going to guess at it. Because if I guess wrong and count it wrong, just so be it. You can't come back and go, but Ms. Perry, that's how I draw my parentheses. No, you don't. No, you don't. No, I ain't buying that. Okay? What in the world is the greatest integer function?
Something we learned him to do.
Like logarithmic.
No, it's kind of funky. But I'm going to wait. Nah.
None of us know that.
Greatest integer function is a step function. And it kind of has this double X thing, this double bar thingy around it. But it's called the step function because it looks like this. Do you see how it has steps? It's closed, it goes across, and it's open. You go up a step. It's closed, you go across, and it's open, and you go up the step. That's all I need you to be able to recognize what that double bracket thing looks like and what the function looks like itself, okay? That's what I need you to look at and be able to recognize. I want you to reference 30:16 in your notes, or about minute 30. Here's what I want you to do for homework tonight, okay? Come on now. What you're going to have to take a picture of this, okay? And I will put a picture of this on Instagram. I'm going to cut the lights off so you can see these. You've got 3 functions, and I'm going to call this function A, function B, and function C. You have to be able to name all of those pieces for each of those functions, okay? But you have to be able to do that. Name that, well, get up. You get up and move. So I'm getting ready to cross, so I cut the video off. Don't take a picture, don't take a picture, don't take